to our latest episode of the online Meetup. Today with us is Rob Hirschfeld, from the founder and Racken CEO. Racken, did I pronounce it correctly, Rob?
we call it Racken. We like to blend the N. Some people like Racken.
Yes. All right. So Rob is going to talk about Crowbar, OpenStack, and the physical DevOps, which is the tough part of DevOps. So let's maybe start, Rob. Why don't you give us a brief introduction? Who are you? What are your current roles, and where are you coming from?
I'd love to do that. Thank you for the introduction. So I play a lot of roles. My background goes back in cloud all the way back into the 90s, believe it or not, and always on sort of the physical data center infrastructure side, trying to figure out how we make it easier to do deployments and things like that. Today, I founded a startup that's working around helping people support and build extensions for the Open Crowbar project. The Open Crowbar project was something that I started with my Racken co-founders inside of Dell as an open source physical infrastructure provisioning tool for OpenStack and Hadoop. That work, we were very early in OpenStack. I've actually been involved in OpenStack since before it was called OpenStack. And so from that perspective, I've been very deeply involved in the OpenStack community, and I'm a community elected member of the OpenStack board, helping drive how OpenStack defines the core of what OpenStack is and do things like that. So I've always had a real interest in OpenStack and operability of OpenStack and how you make OpenStack work in a stable, reliable, repeatable way, how we help the operator community embrace what OpenStack does and then really become part of the conversation in driving OpenStack forward. And so that's a lot of what my focus has been on for my whole career professionally. In this latest transition with Racken, we're really able to focus much more on the software side of ops, sort of making, let me define what Crowbar does and what Racken does on top of Crowbar. Crowbar is an orchestration infrastructure that allows you to run a variety of different physical gear, so different types of servers. It then provisions operating systems. It sets up networking. It does out-of-band control for the BMC and control layers. It sort of takes care of all the operational elements that are needed to coordinate bringing up the system. And it does it without having an opinion about if you use Chef, Puppet, Salt, Ansible, or we don't have a CF engine integration, but we're unopinionated about that. So you can use bash scripts if you want to do things. We're unopinionated about the hardware. We're actually working to be unopinionated about the provisioning infrastructure. We'll talk about those things. But the number one goal for us has sort of crystallized into the concept of ready state, and what we're defining as this physical ready state. And the goal has become being able to create a physical environment that was very repeatable, that was automatable, that you could take the DevOps tooling and the scripts that you use to build any application for us today, OpenStack, and make it work in multiple physical environments, make the same automation, the same configuration scripts work, whether you were deploying on Dell or Cisco or HP or Supermicro or Open Compute gear. If you had a 100-node system or a 1,000-node system, all those variations that make hardware really hard, we felt was really important to abstract so that we could then create a community around the operation of OpenStack. So, long answer. Was there something else you would have me add and highlight?
Well, great. Thanks a lot, Rob. So as for the logistics of today's talk or session, so you're going to provide a brief presentation in the first place, Rob. In case you guys who are attending us live, in case you have any questions, please ask them while Rob is presenting in the chat window on the left-hand side of your control panel. I guess that you will answer those questions after your presentation, which will, I would say, transition into a conversation. So the total time will be approximately 45 to 50 minutes. So with that, let me hand over to you, Rob, and the stage is yours.
And I'm happy to take questions as we go. And what I'd like to do is keep this balanced. I'm very happy to have very detailed conversations about Crowbar. We're really excited about that technology because we're in our second generation. We're actually just releasing our 2.1 version. And so we've really built a lot of extensibility here. What we feel like is important is understanding the ready state concept because a lot of what we've done is help build technology that makes it possible to do that work. How the technology works is interesting, exciting. I've uploaded our technical deck into the background here so we can go through that if people have questions on exactly what Crowbar is and how it operates. And I'll go through some of that as we go. The thing that I was hoping to focus here is ready state because I feel like when I've talked to people in the OpenStack community, and it's not just OpenStack but any of the platforms, the challenge we get is that somebody's configuration doesn't translate well into the next person's configuration, and so we end up not being able to reuse and relearn because we spend so much time figuring out what the impedance match is between one person's deployment and the next person's deployment. And so our hope is that by getting somebody to a ready state and making that ready state very functional, we can improve how things work. And so we've been having a lot of conversations with people to try and define ready state so they understand it. And this was a blog post I wrote, in April, so 6 months ago, trying to define this. And then if you go forward from here against my blog, and you'll see some ready state in the community where we're extending that into networking. John Willis has done some interesting work extending ready state into networking and networking topologies. The idea is to create the same type of IaaS infrastructure and readiness that you have in virtual that you would get in physical. So ready state says I'm going to provide somebody with a machine that has the drives configured, the networking configured, the operating system configured, that has a way to attach to the machine, so SSH keys installed. Some people would go further and say it has to be in my inventory system. I definitely think it has to be in your DNS infrastructure, has to have your time protocol synced up, right? Everything to make that machine ready to operate. From our perspective, that would mean that if you knew how to install OpenStack, you would just be following the scripts. One of the things that Racken did, and we're going to be releasing for people to play with, is a PackStack demo. So you can actually go and use Crowbar to prep an environment, physical or virtual, and then PackStack just runs. You type one line of command, and then PackStack just does the install against all the systems. I'm going to produce a video of that so people can sort of walk the steps in doing that. But what we really found was by separating those two steps, you can have people who focus on getting OpenStack working, and it doesn't matter if it's PackStack or Chef or Puppet or Ansible or Salt, right? You're using your tooling of choice. You're building the expertise for how to run OpenStack. And the same thing could be true for Ceph. If you had to build a Ceph cluster, you build that outside of OpenStack. And then run that through, and that really ends up being what the ready state infrastructure looks like. Okay. So why is this hard? If you're not familiar with physical infrastructure, the thing that makes physical infrastructure really tricky is that there's a lot of variations in the actual pieces and parts that you use to install it. The simplest one that we found is networking. So when you go bring up a piece of physical gear, most of the OpenStack compute nodes that I've seen have somewhere between 6 and 10 network interfaces. And let me see if I think I have a picture of this in the. I'm not going to try and jump. I'm going to let me help you visualize this, and it's in the text here also. But a regular compute node is going to have a BMC interface. It's going to have an administrative interface. Most servers have multiple 1 gig NICs on the baseboard that people don't even plug in. And then they're going to add in a 10 gig NIC. Often they'll do Teams 10 gig NIC for the main public network. They'll use VLANs on that network to segment private and public traffic, and then very often they'll throw in another 10 gig Teams network for a storage network so that they can run their virtual machines against a storage backplane. So I just described 11 NICs, physical networks in a machine, and if you're familiar with physical hardware, those NICs don't enumerate consistently depending on what the networking cards you have and the servers that you have. And even if you were to use the logical namings, those would still vary depending on what cards you had and how the systems were configured. So a very concrete example, the challenge is if I was to write a chef cookbook that assumed that I was attaching to bridge 0 for my Teams 10 gig NIC, my bridge 0 might have nothing to do with somebody else's configuration because they might not be using a bridge. They might be using ETH6 because that was their 10 gig NIC. Or they might be using virtual machines and they're going to just use ETH0 to do their testing scripts. And those sound like maybe small nuisances, but when you're building a script and somebody has to change all of the Ethernet ports that you're attaching your Nova controller to, all of a sudden it becomes a really big deal. That script doesn't translate well. And if the configuration isn't set up correctly, then all of a sudden you're troubleshooting not the configuration scripts, but your whole physical infrastructure configuration. Am I talking on the network? Is my networking right? And that's really just the simplest example. You throw something like Open vSwitch on top of that, or some of the software-defined networking, and now you've got, I just saw a blog post where somebody had shown a picture of an OVS network that had channels tunneling through different OVS layers to different Ethernet ports. And all that stuff, if you have to set it up by hand, you're going to be really tired after just 1 or 2 of those systems. Try doing 100. And if you've made a mistake, you have to go back and repeat that configuration. And that's a lot of what I feel like has been bounding whether or not OpenStack can accelerate in the market. The fact that there's no consistent way to build an Open vSwitch infrastructure on a physical node that you can then lay down OpenStack on top of. And that type of challenge has been a really big part of trying to make all this stuff go. That's from a network perspective. I'm gonna pause and let people ask questions for this if you have them, and I'm happy to answer them. I can happily keep going and trying to explain how these things go. But I love the interaction and trying to figure that out. So while people think about questions, I want to step back and talk about what we did with Crowbar and how Crowbar solved these problems. So what I did was I just described sort of this messy physical environment. The way that we address this problem is there's a couple of things. One is we automate the configuration of the networking. So the networking is configured in a consistent, repeatable way. And then it's abstracted. So we have this concept of functional operations. Let me bring up some more. And we found that people really can understand this once we've explained it. It's pretty common. We're seeing in some of the cloud. Sorry. What we're seeing is it's really common in some of the cloud deployment scripts to start using attribute injection. I know Ansible has like an inventory file where basically common information that's needed for the deployment is abstracted, and then you inject it based on what your deployment is. And that type of gap allows you to then functionalize your operations. And we found that this was a really important aspect of physical more than anything else. So we believe very strongly that instead of trying to make, say, a Kickstart file that has a lot of complex logic and says, all right, here's my Kickstart file and it configures my network or it adds in these capabilities, What we've done with Crowbar is we do those actions as individual actions. So they're layered deployments that happen as individual pieces. So setting up the network is not a script that is part of my kickstart. The challenge with that is I'd have to rerun that kickstart, potentially even rebuild the machine to change my networking. That's really not an acceptable way to do physical operations. It's much too expensive. So what we did instead was we broke networking into very discrete pieces. I need to set up this VLAN on this interface. Okay, that's one request. It's one what we call a conduit, so you can map it. And then that conduit definition becomes an output from one layer and then an input into the next layer. So when you're building up an OpenStack deployment, your public network, you're going to build a public network, a private network, a storage network, an administrative network, and that's just to run OpenStack. And I've seen OpenStack deployments that have more network layers than that. In that environment, you have to know that you're going to attach the Nova controller agents to the administrative, the control network, and then you have to know that you're going to attach the virtual machines to the public network and also to the private network, depending on how their systems are bounded. And what we've done is we said, all right, that's not one network. It's really 4 networks. Each one is configured differently. It has different requirements, different priorities. And what we want to be able to do is define our deployment scripts to say, all right, when I set up an OpenStack controller, I know that my public network is defined as this interface or this IP address, and I can pass that into just that script, and the script can then operate expecting to be told which interface to attach to instead of assuming it in the code itself. Right? And we call it functional operations. It's like functional programming. The idea is that each layer can operate based on its inputs only without making assumptions about other things. When we did our first version of Crowbar 4 years ago, we did resolve these things using search. And what we found out was that while search worked very effectively, it was very difficult to isolate dependencies between these layers. So if somebody made a change to the OpenStack keystone and changed the way data was stored, it could break things downstream. It would be very hard to detect. And so one of the things that we found is really important from a physical perspective, it's important in any operational perspective, is to be very clean about having these functional boundaries. So when you say, all right, my OpenStack, and Crowbar has a concept for this where you actually can say, I need these attributes passed to me, and I produce these attributes as outputs. So when you say, I'm going to build an OpenStack controller, you can say, all right, I need a public network with this on, and tell me what interface it's on. And so you can expect to get data in a reasonable way. That component allows you to then create the controller setup in a very abstract way. And then it can be used across multiple sites. It can be used and tested on virtual machines. It can be tested on gear with one capability or not. And part of what we had to do in Crowbar was create this conceptual boundary where you're not just asking for an interface, you're actually asking for a network capacity. So when we bind a network, we're actually binding to a 10. You're asking for a 10 gig network or a 1 gig network or the fastest network available. And then we allow those things to be abstracted so that the networks are then consistently built no matter what type of physical gear you have. So attribute injection has been an important part of how Crowbar works. And I'll drill into the graphic a little bit so you can see what we're talking about with this. In this case, Crowbar uses an internal engine called an annealer. So when we operate on systems, we do it in a multi-threaded way and in a very atomic way. So we decompose a big deployment down into very small steps. The smaller the better from that perspective. And each step gets the data that's needed for that step. It's a functional step. It processes it based on what that work is. It doesn't really matter what the work is, what the worker is. It could be Chef, Puppet, Salt, Bash scripts. This graphic doesn't show it, but in another model, you could actually do it as a API call that was completely out of band. So you could talk to the BMC interface of a system, or you could talk to a inventory management, or you could talk to the switch and do configurations on the switch to match simultaneously. And then once that work completes, it brings back the output of that data and then passes it down into the next layer. And so building each one of those atomic layers ended up being a really important part of being able to scale deployments. What it also means is that if somebody makes changes to one component, it doesn't have a lot of downstream impacts. And that, in turn, allows us to be much more heterogeneous in how things work. So a really good example would be if you were doing Bash configuration to set something up, and you needed a value out of an IPMI configuration tool. That configuration value would then could be passed back into the system, normalized, and then passed into a Chef cookbook that could execute on building, say, the networking. Most of our networking code is actually Chef. That then exits out, gives you back some data. That data could then be passed into PackStack as this is my network configuration, and you can bounce back and forth between these different tools. And that allows you to not be as constrained into a single way to do things. It allows us to share learnings and things like that. So if somebody had a really good OVS configuration, but it only worked, it was written in the Chef DSL, you could still conceivably use it against an Ansible deployment that built the Nova controller up on top of that. And that's what ready state for us is about. So ready state means you're building this environment up to get it into a place where you can then run an Ansible playbook if you wanted that did the OpenStack compute pieces. And then if you felt that SUSE has some really strong Chef cookbooks for Ceph, and if you felt like those were the right things to do, you could then lay those down in here as a Ceph deployment outside of OpenStack. One of the things that we felt was important for that and really changed between Crowbar 1, which was our first version. Crowbar 2 was started over 2 years ago. It was released in April as our .0. Is that we didn't want to have Crowbar isms, as we call them, inserted into the cookbooks, which meant that this attribute injection pattern was really important for us. And it also meant that search was not going to be acceptable, because if you substitute non-Chef components into the system, you still need to be able to get the data. So attribute injection ended up being a really critical component for that. And then ready state ended up being an important line, because in some cases you want to be able to say, look, I'm done. You get the physical environment set up and then stop messing with it. I'm ready to go do my thing. I want to set up my I don't want, you don't have to have Crowbar run anything else. You could use something like Fuel to then do the deployment on top of deploying images. Our goal was really to help people get to that baseline. Okay, I'm going to pause again for questions.
Yes, there are a couple of questions. So
okay.
I'm very new to Crowbar is one question. What is the difference between Crowbar and Mass?
It's an excellent question. So Mass is Ubuntu's Metal as a service. It's an extension, some modifications from Cobbler. So Cobbler, Mass, Razor to an extent, and actually I have some slides that are ironic I could put up. Their job is to really install an operating system. That's the predominant thing that those systems do. Is they'll allow you to PXE boot. They'll set up DHCP, and they'll respond to those requests and lay down the bits for an operating system. Crowbar has a component like that called the provisioner that does similar things. It handles it handles a DHCP request. It will tell the systems to make the appropriate PXE boot and lay down a kickstart. We're actually working to abstract that component laying down an operating system is just a small piece of the control flow for Crowbar. Crowbar is really an orchestration engine that sequences out all of these operations that need to get done. So, for example, when you're building up a physical infrastructure, after that operating system is installed, you want to do things like we lay down a squid proxy, which allows you to have a lot better performance through your internet connection and channels all of your outbound server I/O, server network requests through a bastion host. So you reduce your outbound internet considerably and you streamline your networking topography. That type of configuration is something that is done post-install, and trying to do it as part of a kickstart would be very cumbersome and difficult because your kickstarts would get increasingly complex. We do that as a post-configuration step. Another good example of how we're different than something like MAS is that we'll actually do BMC management and control in this. So when a system's booted, we'll discover that image, we'll do an inventory, we'll configure its out-of-band networking, or out-of-band control planes if it has it, and then we'll start talking to it on the BMC, out-of-band control ports. And so we can do configuration from that, we can turn things power on, power off, we can make all sorts of changes. And then we can also start talking to external systems. So we could do an inventory post, we can do DNS entries for other systems. It's much more of a system coordination tool, and then we can use things like Cobbler to actually lay down the OS. And that's one of the things that we're working on right now is being able to leverage Cobbler. A lot of people we talk to have Cobbler working in their systems. It provides a useful, you want it to lay down the OS. What we found is that people are very frustrated trying to maintain increasingly complex kickstarts. And injecting a lot of logic into the kickstarts means that you have things that work for you, and it's much harder to share the operational tools for that. It's not DevOps tooling per se in a DSL that you can really take and make portable. It really is a kickstart that ends up being pretty unique to each site. And so to deploy an OpenStack cluster, so the second question, I hope that answers that question. I can show you, I've been trying to coordinate some work with the Ironic team to explain how this would work. So this is draft. I'm still waiting for some feedback from Ironic PTL about this. But the idea here is that Crowbar's job in the today model is to build and lay down the physical infrastructure, get everything ready, and then you can build up basically dedicate systems to OpenStack. Inside of that, you can use Ironic if you want to do multi-tenant shared physical infrastructure. We would turn over control of the nodes to Ironic, and Ironic would then be responsible for re-imaging and building. Over time, the Ironic did I lose the audio?
No, it looks all great. There seems not to be any issues.
Sorry. No, I thought I dropped it. Good. Okay. So over time, the Ironic system would actually take the place of the provisioner for us. So you could use Ironic. We actually would see this as being, you could use Ironic, you could use Cobbler. If you were provisioning network switches, there's Cumulus uses a technology, and there's several other vendors are adopting it called ONI, which does switch boot and install. You could use Razor. We're pretty agnostic about that. And so what we feel like is the real challenge to create ready state is an orchestration problem, where you're creating a very consistent sequence of steps that leaves you at an end state. It's more than just building the operating system and installing the operating system. It's back to this is why I spent so much time on functional operations. It's back to creating functional ops and trying to segment those layers, and that allows you then to have very clean attribute injection. Our concern would be that as soon as you have somebody building a fancy Kickstart file, it's going to work great for them. It's going to be hard for you to translate it. And and so we needed to get sort of a broader orchestration that allowed you to make all those things work. And so what Crowbar does to prepare for Crowbar is Crowbar actually builds a full physical operations environment. It'll actually build a DNS, DHCP, a Pixie server, NTP server. It'll install. It'll actually figure out how to build Kickstart, so it'll build some custom Kickstarts, or depending on which OS you're using, because we're heterogeneous from an OS perspective. So it'll build the install images for those components, Squid proxy, things like that. Believe it or not, it does all that from an RPM. So you can take an RPM and it'll install a very minimal web server database, Postgres database, and background threads. And then it will, in a bootstrapping model, it'll actually SSH back into itself and start installing all the data center operations components that you need. And that's been one of the things that we've seen, is that to make this work, you actually have to be able to control all these different data center operational pieces. So today, Crowbar is really focused on sort of owning all those pieces. And we're actively, this release, so we just started our C release, which will be the 2.2 release, and in that release we're working on integrations into other operations platforms, so going out and using somebody else's DHCP server, or an existing DHCP server, or using an existing cobbler interface, or using external DNS. We really felt like that was one of the next major hurdles for getting OpenStack integrated into people's environments, was not just saying, hey, I can deploy OpenStack and it's a nice clean little box, but actually making it part of a broader operational framework. It's worth noting, so once you build Crowbar like that, and there's a Docker version where if you're going to be doing a lot of cycles, there's actually a Docker version. You can boot a Crowbar in a Docker container, connect that Docker container to a physical Ethernet port, and then boot physical nodes off of it. We do that all the time. It's pretty straightforward. Crowbar has, the core of Crowbar doesn't do physical configuration at the RAID and BIOS level. There is a open source hardware extension that does do the actual RAID and BIOS configuration of the systems. So the core, if you will do IPMI and external control. But by adding in that hardware piece, it'll recognize gear that it has drivers for, and it'll actually do the RAID and BIOS configuration. Today, that's Dell gear. This was originally a Dell project, so we have a considerable amount of Dell support for that. We also have some Supermicro gear because we use that for testing. And then we're happy to engage with people in the community who want to actually have RAID and BIOS configuration of other types of gear. We've been talking to people, to prospects who want to help pay for HP gear, Open Compute, Cisco UCS, IBM. It's not IBM gear, but so there's a couple of different places where we can do those extensions. Crowbar has the capability, because of the way the orchestration works, to understand how blade frames and tiered gear operates, so that you could reach past a blade frame. That would be possible. It's not an integration that we've done yet. And like I wanted to stress, none of those integrations are required to boot and run Metal. You can boot and run Metal. You're just not going to get the benefit of setting the RAID configurations or setting the BIOS configurations. It really comes back to what drivers you support and how you support them. The design allows us to support a wide variety of gear. But if you've dealt with physical gear, you'll know that and we actually call it the quirks file. Every gear has its own quirks.
Okay, there's one more question that just came in. Is there any walkthrough for deploying OpenStack Juno to several bare metal servers we can refer to?
I'm in the process of I'm building a video, and I can distribute. Raf, do you have a way for me to get people back some information through this list, or I guess we have the meetup?
Yeah, we can do this later on. Yes.
Okay. So I don't have a public video yet with a walkthrough on that. That's actually one of my activities for the next day or two to build that, and I can distribute it. I'll post it on my blog also, and you can walk through how to do it. We hadn't we hadn't decided to. This is worth explaining. We hadn't decided to open the PackStack demo to the public until this week. Our company, Racken, is not an OpenStack company. We're not in the OpenStack support business. Our goal is ready state hardware, and we want to help people get ready state. And we're actively talking to companies who want to partner on the OpenStack side, who do OpenStack deployments, and they have a specialty with that. Our PackStack deployment is literally an out-of-the-box PackStack deployment. It's handy. It allows you to build, take a 6-node cluster and deploy PackStack on it. Racken as a company is not prepared to do OpenStack consulting and help people tune that into production-grade OpenStack and create HA OpenStack clusters. We will happily talk to customers who want to build that expertise, or partners who want to have use their OpenStack deployments on top of it. SUSE is a great example of somebody who did that with Crowbar 1. So SUSE's deployment, and I love to plug SUSE, very quietly has built the best OpenStack deployment in market. It's arguably that way because they have twice won the Intel Challenge at the summit, and they were able in 1 hour to do a fully HA OpenStack deployment that passed Intel's HA challenges, 3 of the 4 HA. They took nodes down, and they tried to actually break the deployment. They did it in an hour on completely fresh gear. They used Crowbar 1 to do that. So a lot of these technologies, Crowbar 2, we continued. Our goal as a company and supporting the Crowbar project has been to enable Crowbar to become a base for that type of integration, that type of deployment. So we will very happily allow people to use the PackStack pieces, make that open, and it's a great proof of concept environment. And then we'll talk to you on either side of how to make that work. Hope that answers your question. And you can definitely do Juno. We have both the Juno and Icehouse PackStack deployers for it, and we'll open the steps, and I'll show a video of how to do it.
Rob, question from.
Yeah.
Sorry, go ahead.
No, what was your
question? From my end. What are specifically the plans for Racken, and how are you going to further develop Crowbar?
Excellent question. So Racken treats Open Crowbar as an open core for the project. We're planning to build extensions, sort of what Ceph has done, where they built management and control planes, alternate UIs, things that help make it more manageable for scale. So Racken's going to be building those. We'll be building networking integrations and helping take Crowbar into networking control and orchestration. And then we're also going to be able to support hardware drivers. So right now, hardware drivers are open. So like the Dell drivers, Supermicro drivers, those are all done in the open. People can use them and take advantage of them. I will tell you that hardware drivers have a half-life. And so Racken will offer support for those hardware drivers. So if you are relying on Crowbar, we'll happily sell you consulting and help you support it, and we'll sell you a support contract so that if you're using it and relying on it, you have a phone number to call and people and experts to rely on. And then if you have gear, we will help you get that gear supported in Crowbar, and then we will provide you with support with that gear on an ongoing basis, so you can count on Crowbar to be able to configure and provision that gear, even as the BIOS is updated and the configurations. Things, unfortunately, hardware is very finicky, and we found that it was always a moving target even with the same gear. So we would find that you would ship servers, and even in between shipment, BIOS would come out, and that BIOS would have breaking changes or incompatibilities that had to be addressed from a scripting perspective. And that's universal of vendors. So the reason people like cloud is you don't have to deal with that. We feel like we provide a lot of value for our customers and community by being able to help them get past their own personal staff dealing with the finickiness of hardware. We sort of absorb that effort for them.
Oh, great. Thank you very much, Rob. There seems to be no more questions from the audience. This is our first session, actually, at the OpenStack online meetup. And we are going to have another one on December the 18th. So maybe you give a very brief outlook. What are you going to talk about in 2 weeks?
Happily. Totally different subject. So in 2 weeks, we're going to be discussing OpenStack Core, Dev Core specifically. So over the last 3 years, I've been leading the OpenStack board through this process of defining what it was to be OpenStack, with the goal of ultimately building interoperability between OpenStack clouds. And so that process it has legal bylaws changes, it has community process and TC interactions, it has a whole bunch of entanglement so that we can be sure that the community has a really defensible, strong, agreed upon core. This is OpenStack. This is what you can count on if you buy a vendor's product. And so we'll be talking about how we made those decisions, how we do that, how we're going to maintain it going forward, and what is core and what is not core, and how people can know what to expect. So it's a really important topic for the community and for people buying and using OpenStack to understand.
Right. So thank you very, very much, Rob, and looking forward to the next session on December the 18th. And thank you, everybody, for joining us and asking questions. And see you next time.
Excellent. Thank you all. I appreciate the time.